Hello everyone. Now we are going to see the numerical problems on electrical quantities. So first of all we will see some MCQs and then after we will see some structured questions. So the first MCQ is given over here. You can see the polythene rod is rubbed with a cloth and you can see the polythene rod is given and the cloth piece of the cloth is also given. The rod and the cloth both become charged as electron moves between them. The rod becomes negatively charged. The which diagram shows how the rod becomes negatively charged and the final charge on the cloth. So which concept is applicable in this question? I hope you remember the static electricity. We had seen the three ways to generate the static electricity. Those were friction, conduction, and the induction. And we had seen for the friction static electricity that the balloon were rubbed over the wooden cloth. And in this process, what is happening? The electrons from the wooden cloth are transferring to the balloon. And since the electrons are negatively charged, this balloon will acquire the negative charge, and this woolen is simultaneously acquiring the positive charge as it loses the electron. So electrons are only transferred. I hope you remember I told you the protons were never transferred, only electrons can be transferred. So the same problem is here when this rod and cloth are rubbed over each other. This rod will acquire the electron, so it becomes a negatively charged, and cloth will become positively charged. You can see in the first option, this is negatively charged, this is positively charged. That is correct, but here electrons are moving from the rod. That is incorrect because a rod should acquire the electron. Now in the question of the option number B, you can see this is negatively charged, this is positively charged, that is correct. An electron is acquired by this rod, that is also correct. Okay. And if you count this number of electrons, this number of negative charge and positive charge, both are also correct. So our option should be this question option number B. Our answer should be option number D. If you see this option number C, both are negatively charged. In D also both are negatively charged. That is incorrect because if it acquires the electron and it becomes a negatively charged, the opposite body should be positively charged. So our option number B is only correct. Now see the question number 2. The wire has certain electrical resistance. The diameter and the length of the wire may be changed. Which pair of changes must cause the resistance of wire to increase? So we have seen the relation between the resistance and the length and the cross-sectional area of the rod. Suppose this is a wire or a rod, and if we assume this is the length of the rod and this is nothing but the cross-sectional area. So what relation we had seen? The resistance of the rod is directly proportional to the length of the rod, and it was inversely proportional to the cross-sectional area of the rod or any wire. Okay, so it is inverse proportionality. So if you want the increase in the resistance, we want the increase in the resistance because in our question we want the increase in the resistance. Okay, so if you want the increase in the resistance, the rod length should increase because this is in the direct proportionality. So if R2 be increased, L should be increased, and if you want the R to increase here, then the area should decrease because it is in inverse proportionality. Okay, and vice versa. If suppose in question they ask the decrease in the resistance, then length should decrease and area should increase. Okay, so we'll see here the options, what options are given. The option number A, the diameter, the options are given like this: change of diameter and the change of length. So area, we can say if the area is decreasing, that means if this is the diameter of the cross-sectional area, the diameter should decrease, because if you decrease the diameter, area should decrease. If you increase the diameter, then area should increase. So in the first case, the change of the diameter will decrease and the change of the length decrease. So those are incorrect because we want the increase in the length, and here decrease in the area, that means decrease in the diameter. So option number B, you can see this is the change of the diameter, that is a decrease, and the change of the length, that is increase. So that is correct. So decreasing the diameter, that means decreasing the area. If we decrease the area, resistance will increase. And here if we increase the length, this if we increase the length, this resistance will increase. So total we want the increase in the resistance. That's why our answer should be option number B. So option number C, you can see here it is given as increase in the diameter, that is incorrect, and here decrease in the length, that is also incorrect. Here it is given increase in the diameter, that is incorrect, and it is given increase in the length, that is correct, but overall option is incorrect. So I hope you understood. Now we will move to the next problem. So the next problem, flexible electrical cable consists of a central conductor and outer insulation. So this is given, the central is the conduction, outer is the insulation. So which pair of materials is suitable for the cable? You can see the conductor, copper is a conductor. We generally use copper for our regular correct connections, and the outer layer we generally use a plastic. So you can see option number B, A. Option number A is nothing but correct option. Option number B, you can see it is a lead and the wood. So lead we generally don't prefer for our conduction wire, and wood we never use for insulation. Outer part is always the plastic. And the third one is option number C. You can see the plastic is already not a conductor. Here the wood is already not a conductor. So our option number A is only correct option. So let's move to the next problem. The next problem. The diagram shows the battery connected to two resistors, and four students separately measure electromotive force, that is EMF, of the battery, the current in the resistors, and the potential difference across the resistor. And their results are shown in the table below, which rows show the values with their correct units. Okay, so here what is our important thing is we have to check the unit, and we should estimate the values. Our main important goal over here is to correct see the units. So you can see this is the battery, and we are measuring the EMF across the battery. You know, the EMF is what? EMF is nothing but the potential difference, which is the maximum and which is present across the battery. Okay, and we are going to measure here the potential difference across this resistance R. So here the potential difference is measured across this resistor R. The options given are this. The EMF, we know the unit of the EMF is nothing but the volt, and the unit of this potential difference across R is nothing but the volt. And when the current flows to the circuit, the current is measured in terms of the ampere. So these units you should know before you solve the problem. Now you can see the options. In option of A and B, you can see the EMF is given as 3 ampere and it is given as 3 ampere. So you can see the unit itself is incorrect because EMF is measured in terms of the voltage and not the ampere. Now option number C, it is given as 3 volts, so that is correct. You can see this is given in terms of voltage, but the current here it is given as 0.30 voltage. So current we measure in the ampere. The current we measure in the ampere, not in the voltage. So that option cannot be correct. In option number D, you can see this voltage is correct. EMF is measured in voltage. The current is measured in the ampere. That is unit is correct. Then potential difference is measured in the voltage. So as far as the units are concerned, only this option is correct. And you can see this EMF is given as a 3 voltage. Current is 0.3 ampere. It depends on the value of the resistance. We don't know the value of resistance here, and the potential difference across the resistor R is 1.5. So it can be 1.5 because this voltage here this is a series circuit, and we know the voltage split in the series circuit. So some voltage will go across this resistor and some voltage will go across this resistor. So the voltage or potential difference across R can be less than the EMF value. Okay, so 1.5 can be acceptable. So here option number D is only correct. Only if you check the units only, then also you can estimate